So today I want to talk to you about why we should even bother with micronutrients. They're micros, but they do play a very important role in whole plant health. So I'd like to start off with some of the basics on plant nutrients and elements, and then dive into micronutrients more specifically and how it applies to West Alberta. So first I'd like to start off with a reminder of the 17 essential nutrients for plant growth and development. So the primary nutrients found in plants are non-mineral materials. So that's your oxygen, carbon, and hydrogen. And typically they take up about 96% of a plant. Next is your primary macronutrients that we're all very familiar with, NPK. And those are just over 2% roughly of what is in a plant. Next, you have your secondary macronutrients, which are sulfur, calcium, and magnesium. And then the micronutrients are chlorine, iron, manganese, zinc, boron, copper, molybdenum, and nickel. And while these are called micronutrients, it doesn't mean that they're less important for plant growth and development. It just means that they're needed in much, much smaller quantities for a plant's health. So when we talk about mineral nutrients, it's important to remember that there's a difference between cations and anions in the nutrients. So cations are positively charged elements, and typically they're immobile within the soil because they can easily bind to soil particles. This will depend on your soil structure and your cation exchange capacity, obviously. So the higher clay you have, the more they'll bind to the soil particle. And the micronutrients that are considered cations are copper, iron, manganese, and zinc. And then on the flip side, you have your anions, which are negatively charged elements. So these are highly mobile within the soil and can be easily leached out of the profile, in particular from around the plant roots. So these negatively charged micronutrients are boron, chlorine, molybdenum, and nickel. So first I'll start off talking about the cations. And the first one I'll mention is copper. So copper is really important for photosynthesis, as well as protein and carbohydrate metabolism. It also plays an indirect role in chlorophyll and synthesis and plant respiration. So it's often more required by monocot crops such as wheat, barley, oats, and grasses that you'll find in grassland areas. The availability of copper does decrease when the soil is greater than 7, so very high pH soils, often you'll see more copper deficiencies. And those symptoms are yellowing and wilting and drooping of leaves, and often you'll see a little bit of pink between the leaf veins. Another symptom that's often seen, especially in our area, is an increase in ergot. So there's still research ongoing about this, but so far what's been found is that the higher the copper deficiency or the lower the amount of copper is in the soil, often it leads to higher ergot. So next I'll talk about iron. It's really important for the formation of chlorophyll, and it's a component of enzymes within the plant that are involved in photosynthesis, respiration, and nitrogen fixation. So you'll more often see an iron deficiency in crops like your legumes, like soybeans, and some pulses. So the young leaves will turn yellow first, but the veins of the leaf remain a very dark green. And it's important to note that iron deficiency is very rarely seen in Alberta. So manganese, the symptoms look fairly similar to your iron deficiencies. However, the leaves have a little bit more green between the veins and venules. So what manganese does is it aids in plant photosynthesis, respiration, chlorophyll formation, and nitrogen metabolism. So it's involved in quite a few different aspects of a plant's growth. Within Alberta, the crops that are more susceptible to manganese deficiencies are oats, peas, and sugar beets. So zinc is the next micronutrient I'll mention. It promotes growth hormones, starch formation, seed maturation, and production of those seeds. It is necessary for chlorophyll production, as well as carbohydrate and starch formation within the seeds. So it's very important towards the later end of a plant's cycle as it's setting seed. Zinc deficiencies are more often seen in soils that have a high sand content and low cation exchange capacity. And it just means that the zinc is less available for the plants to uptake. Corn and beans are the most sensitive to zinc deficiencies, so it's not widely seen across all crops, not as evident as with corn and beans. So the deficiency symptoms occur in older leaves. They narrow in size and look quite stunted, with a pale coloring and dark spots. When you see a zinc deficiency, it's generally quite obvious. So the next micronutrient I'll touch on is one that is mentioned quite often within Alberta, as canola is one of our primary crops, and that's boron. It's essential for pollination, both pollen tube growth in a plant and pollen grain development. So if you have low boron, you have lower chances of those structures forming at flowering time. It's also essential for seed and cell wall formation. And as I mentioned, it's required highly by canola and other legumes, and very rarely in your monocot or cereal crops. The availability of boron decreases just like copper when your pH is greater than about 6.5 or 7. And the deficiency symptoms of boron are typically seen at the top of the plants in the youngest leaves that will yellow and get thick. And you'll also have very obvious leaf discoloration, leaf bud discoloration and breaking off and dropping. So obviously, in the end, that can affect your yield. Within Alberta, it's been shown that about a 0.3 part per million or less of boron in a soil test will show greater deficiency symptoms and will affect the plant even more. However, below 1 part per million in the soil, you may start to see some of the symptoms. It just might not be as obvious, but it can affect your yield and your crop's development. So next is chlorine, and this is in Alberta, but I'll touch on it because it is important for plant growth. It's involved in light reactions as part of the photosynthesis process, and it aids in root and shoot growth. It's used by plants to regulate turgor. So turgor in a plant is its ability to stay strong and upright. It's a pressure from water within the plant that does that, and so essentially it regulates the water flow within the plant and prevents loss through stomata. Low soil pH can promote the uptake of chlorine, and deficiency symptoms are usually seen with reduced plant growth and yellowing, spotting on leaves. And as I mentioned, soils in Alberta, thankfully, we don't have many issues with chlorine. Molybdenum is another micronutrient that we don't see deficiencies very often in Alberta thanks to how our soils are formed. It's essential for nitrogen fixation and assimilation, and it plays a really big role in plant nodulation overall. So often symptoms are seen more in your legume and pulse crops. It's necessary for converting inorganic phosphates to organic forms within the plant as well. And deficiency symptoms are often seen when you have stunted growth on older leaves, as well as yellowing and spotting. And finally, the last micronutrient I'll talk about is nickel. Nickel was only just recently seen as an essential plant micronutrient. It assists in nitrogen fixation as well as the utilization of ureas within a plant. And it assists in plant disease resistance in some cases. More often, you'll see toxicity in plants and not deficiencies, but there are areas of the world where deficiencies are seen. And the image here is actually of pecan leaves. Apparently, pecans are very sensitive to deficiencies. On the opposite side of that, when it comes to toxicities, oats can be very sensitive to too much nickel. However, that's not often even seen here and is usually from contaminated fertilizer added to the soil, things like that. So in Alberta, we're more concerned about a toxic effect than a deficient effect, but even that isn't seen very often. So to quickly summarize, I found this really great image from Montana State University that shows often where you will see those deficiency symptoms within the plant. And this includes macronutrients as well. And it gives kind of a really good imagery of what those deficiency symptoms look like. So bringing this back to where we are, Yara Canada has done a study of soil tests recently and published the data that they saw. So the percentage of fields showing micronutrient deficiencies based on soil tests in Alberta showed that copper, boron, zinc, and manganese are the most deficient micronutrients within our soil, with copper deficiencies being highest. However, this is based on the number of soil tests that were done, and we know that soil testing isn't done on every single field. And if you're not careful, there can be inconsistencies. However, a lot of the soil tests that I've been seeing this year, this follows. In Northwest Alberta, I'm seeing a lot of boron deficiency and quite a bit of copper deficiency. Boron right now is likely due to the high amounts of rain that we've had because it is so mobile within the soil profile. So that's something to really keep an eye on. And obviously the best way to know if you have a micronutrient deficiency is to test your soil. And then in season, you can do plant tissue testing, but also watching for those symptoms that I talked about. So again, just to recap a little as far as crops that we grow, boron, obviously, like I said, at a level below 1 part per million, you can start to see effects on your dicot plants, like your canola or your legumes, faba beans. So you want to watch those levels. And then copper in your cereals, if you have a level below 2, you can start to see copper deficiencies and at times increased ergot infection. Zinc is often seen in corn or your bean crops, so you'll want to keep an eye on your levels of zinc that are added to those fields and make sure that it's above that 3.1 part per million as an ideal. And then lastly, manganese. In our area, oats and peas are very susceptible. So you're going to want, on your soil test report, you'll want to watch your manganese levels quite closely for those crops. So that's all I had today. It was just a very quick overview of what micronutrients do for a plant. And just as a quick reminder, even though they're considered micro, it's not that they have less importance. It's just that they're needed in much smaller amounts to be taken up by the plant for its overall growth and development. Obviously, when you're talking about anything with soil, soil is very complex, and this was a very brief overview of micronutrients. And there are entire classes and master's projects on this. So this is, like I said, just a very, very brief overview of micronutrients. Next week, Wednesday, December 9th at 9 a.m., we'll have a continuation of this topic discussing forms of fertilizer that can be used to help and treat those micronutrient deficiencies that you might be seeing in your field, either through soil tests or through your plants. And then December 16th, again, it's a Wednesday at 9 a.m., we're going to discuss the logistics of adding those micronutrient fertilizer products to your overall blend. So thank you so much for joining today and watching this presentation. If you have any further questions or concerns about what's going on in your farm, please reach out to your local rep or myself, and we would be really happy to help you with anything you might be dealing with. And hope to see you the next 2 Wednesdays as we continue this micronutrient discussion.